All right, so class, today we're going to talk about using the law of sines and the law of cosines. And if you look at this, it's literally just problems that people, deal with on a normal basis, average everyday real world application problems that can only be solved with law of sines and cosines. A bit sarcastically here. But anyway, I'm not going to tell you use law of sines. I'm not going to tell you use law of cosines. You got to kind of figure that out. Looks like a lot of triangles. Looks like a lot of missing sides. Do y'all have the answers on there too? Yeah. Oh, y'all are so lucky. All right.
Wait, do we?
You have the answers on the back?
No.
All right. In these problems, the way that you're going to solve it is law of sines or law of cosines. So, as far as I'm concerned, once we figure out collectively as a group whether you're going to use law of sines or law of cosines, I'm kind of okay with saying, okay, law of cosines that up, let's go to the next problem. Because last week is when I taught you how to use law of sines and law of cosines. Does that make sense? So this week is just, today is actually figuring out which one of those would apply. And we could spend more class time if you would write it up, sine of this over this, equals sine of that over that, and let's multiply together, let's take the inverse sine of the, you know what I mean? I say, maybe we'll set it up. And here we go. Ryan and Lena are standing on a riverbank. Oh, how nice. 180 meters apart. We got some sort of disagreement between them. At points A and B respectively, per the figure below. They want to know the distance from Ryan to a house located across the river at a point C. We need a motivation here. Why does he want to know how far it is? Is that their house? They've been separate. They went across the river and now they're mad at each other, and he's going to try to swim back home to. Yeah, before the house burns down. I don't know. Maybe they're, maybe they realize that, the baby is there untended. I don't know. Okay?
No, I left the baby in the house across the river.
Exactly. I'm not sure why exactly. Maybe they are going to race back because their favorite show is coming on, and the game or whatever. All right. So anyway,
who keeps the house? They just divorced.
Oh man, that's here. So such a dark story here. They want to know the distance from Ryan to there. Okay, Ryan measures angle A. So he looks at Lena, and then his eyes turn back to the house, and he says, that's 40 degrees. Okay? And Lena looks at him, and then she measures the angle, and she says, oh, that's 60 degrees. Okay, that's interesting. What is the distance from Ryan to the house? Round your answers to the nearest tenth of a meter. Well, I don't want to, when I look at all this, I just sort of simplify it to its most basic parts here. So we got a 40 degrees, 60 degrees. I guess we could call this R, and we could call this L, and we could call this H. 1, 2. And then across from R, we could have little r. Across from L, we could have little l, which looks like a 1, so I'll make it cursive. And then across from H, we have little h. And notice they're not wanting little r over here, they're wanting this distance right here from R to H, so that's what we would call little l. Okay? Do we know this angle right here?
Yes, we do.
What is that?
80 degrees.
80 degrees. 40 plus 60 is 100, subtract it from 80 degrees. Okay. I'm open to suggestions. Law of sines, law of cosines. Law of sines? Yes. What made you think that? Elaborate. Because we're given two angles. Yes, that sounds great. Yes, given two angles is normally an indication that you want to use law of sines. So we'll set it up for you, okay? So we'll say, oh, H right here is 180. So sine of, let's let's see. I need something that I know, so that I know those two guys. So sine of 80, or if you want to do it as letters, sine of h over little h equals sine of, I'm looking for this one over here, so I better put angle L right there. Sine of L over little l. Do we know everything? Or almost everything? We know h is 80 degrees, little h is 180, L is 60 degrees, so sine of 60 degrees over little l. Do y'all think you could do the math on that? Multiply both sides by L, then reciprocal, yada, yada, yada. At this point, I'm just going to say dot, dot, dot. We took care of that last week. What I'm concerned with today is us identifying law of sines, law of cosines, and how to set that up. If we finish this maybe in the next 10 minutes, maybe get some extra time to work on these problems for yourself. Sounds like a winning idea. And we get to come up with a compelling backstory for the two airplanes. Two airplanes leave an airport at the same time. Ryan and Lena now going farther and farther away from each other. An hour later, the planes are 234 kilometers apart. If one plane has traveled 285 kilometers, and the other has traveled 280 kilometers, find the angle between their flight paths. Okay, so this angle right here. See the figure below. I see it, and I'm going to give it a label. I'm going to just go A. Actually, that makes more sense for the airport, wouldn't it? A, B, C. Cross from the A, little a, cross from the B, little b, cross from the C, little c. And they're wanting us to find the measure of that angle. We now need to think, do we use the hammer, do we use the screwdriver, wrench, or the ratchet? What are we going to be? Law of sines, law of cosines. Which tool, class?
Cosines.
Why do you say law of cosines? We have all the sides, and law of cosines is good for a side, side, side situation. I don't remember law of cosines as well as I remember law of sines, so somebody just tell me the law of cosines generically. You might need to look it up in your notes there. Grace, you got something for us for law of cosines? It can be any one of the three forms because they're all pretty much the same. Grace is going to start us off with. Yeah, looking for one of the sides. Like for instance, oh, you want to give me the version that has the angle?
I don't know.
You don't know.
I think she meant cosine B equals.
Equals, yeah.
Okay, cosine B equals. Sure, that'll work.
B squared minus A squared minus C squared divided by 2AC. I don't know if that's right.
Yeah, that's right.
Okay.
Just a little confused.
All right. The alternate form was like A squared
Minus B squared minus A squared.
minus B squared. I thought it was plus. A squared plus B squared minus 2AB cosine C equals. No, it was any side squared equals the sum of the squares of the other two sides minus 2 times their product of the cosine of the included angle. Alright? And then what we could do is you could rearrange that so you could have the cosine of some angle is equal to the difference between those two other sides. And anyway, yeah. Okay. So I think this kind of, now this doesn't match up with that particular one, but this is our generic form. Okay, so in our case, we want to figure out what's the cosine of angle A. So let's go ahead and apply that formula. So someone other than Grace.
A squared minus B squared minus C squared over negative 2BC. Or if you want to
Well, now hold on. Now, here's the question. Which one is, you said, okay, you're putting a squared because you said that you noticed that those have to match. Is that what you, okay, yep, I agree. And then down here, the two sides correspond to those two guys, which are those. Yes, I agree. And at this point, that looks like a 9. So we could just plug in the numbers. 234 squared minus 280 squared minus.
Would it be easier if you just found one with law of cosines and then used law of sines?
Okay, like you mean like found like one of these other angles?
Yeah, so like just find cosine A. Because I think it's faster to plug it in.
Well, here's the, okay, so possibly. Let me finish writing this out and then we'll do that. So minus 2 times 280 times 285. And I do want to see if we can actually key that all in. Okay, so hold that thought. Let's finish this train and then we'll compare and see if it is faster because it might be.
Wait, would it be 2 times 234, 285?
Possibly. I didn't really pay much attention to what it was.
No, I'd be 280.
It's the way the formula was. It was 2 times this the second item and the third item, which was 2 times B times C. So 280, which was B, and C 285. I don't know what I had written a second ago, but I think this is right now. Are y'all in agreement? Sarah says yes. All right. Cosine. Tell you what. Give me the decimal there. So now remember how we want to do this. You know, I would recommend strongly you put parentheses around that whole numerator, and then you can do divided by, and you can put brackets or parentheses around that whole denominator, hit enter. I want to see everyone keying that in. I'm walking around and do a calculator check just to make sure that we know how this works. So 234 squared. 280 squared. 285 squared divided by 285. I got 0.65707.
That's what I got.
Y'all are so smart. Just be brave about it. So show me 0.65707. Do you need a calculator? There's one for you. Okay. If you can't do it when I'm spelling it out for you, then you're not going to be able to do it on your own. Yep.
There you go.
He's got it. Ryan, did you get it?
I did not.
Okay.
What's that?
And then, do y'all remember how we take it home here on this one?
Inverse.
Do the inverse cosine
Time.
of that answer. So don't feel like you have to type in 0.6, so just use inverse cosine answer.
48.9.
Say it again?
48.9.
48.9 degrees. Let me go over and see if that is correct. 48.9 degrees is correct. Okay. Now, Dominic has a suggestion that might be a time saver, so I'm gonna definitely think of it. Okay, so you suggested what?
Just like picking one of the sides, so like cosine A, solving for that. Solving for the vacant A, and then once you have that, you can just plug it in through law of sines.
Okay.
So you only need to find one of them to be able to fill out the other equation.
Okay. So we want to go to the point where you do like sine of A over 234, right? like sine of A over here. Like, what you're hoping to get is to be something like equals sine of angle C over 285. Because you know this one and you know this one, and we want to know this one. This is what we want.
And you only need to know that.
Then we only need to know sine. We only need to find C, right?
Yeah.
I totally agree. I think that's a good idea. So now here's my question for you. How are you going to find angle C?
Well, isn't that what we're solving for when we do the cosine?
Yes. Okay, so you say do law of cosine.
So but only do it once instead of having to do the full equation 3 times.
Right. Well, here's the thing. We did not need to do did we need to do full equation 3 times here in order to find angle A?
No,
We only need to do it once in order to. Those 3 equations were just different. Okay, so if this was asking for all 3 angles, then what you're suggesting, absolutely correct. Okay? If it was asking for all 3 angles. Because you would use law of cosines once, and then you would use law of sines to do the other one. And then you would do, like, add the 2 up and subtract from 180, okay? If it's just asking for 1 angle, though, then it makes the most sense to just do law of cosines on that particular angle. Otherwise, what you could do is like, well, let's do law of cosines on this angle and then do law of sines to find this one. And you'd be like, well, why are you doing law of cosines for this angle so you can then do law of sines to get this one? Just use law of cosines on this angle.
I thought you had to solve all 3. You realize
Right, right. That's why I said, yeah, if you were going to have to solve all 3, like solving which was like the homework law 2, I think it was, absolutely, yes. So
for this one, it's only going to ask for 1 angle. Like
yeah. So in some ways, law 3, this particular homework is easier than the previous one.
Huh.
Because you only need to find 1 piece of the triangle. Okay? Now there is it is a little bit more difficult because you have to decide whether you use law of sines or law of cosines. But I don't think for y'all that's really difficult. Oh, time to go get a tree. As shown in the figure below, Gina is standing 82 feet from the base of a leaning tree. Watch out there. The tree is growing at an angle of 81 degrees with respect to the ground. The angle of elevation where Gina is standing to the top of the tree is 41 degrees. So she measured, if I look straight at the tree and then I kind of move my eyes upwards to the very top, that is 41 degrees. Find the length of x of the tree. Okay, let's go ahead and have some letters here. So we got J, and then here we have T for, actually, and then, I don't know, some of the letters, B. And they're wanting us to solve for x, which is that side. Any suggestions, law of sines or law of cosines?
Sine.
I'm here. Why did you say law of sines?
2 angles.
2 angles. Okay, so we've got 2 angles that seem that we're looking for a side. Yep. So I would say the sine of what over what equals the sine of which over which. What do you got there? Speak up there, Brianna.
The sine of 58 over 82 equals sine 41 over x.
Sure. Now, where'd you get that 58 degrees?
41 plus 81, and then subtract that from 180.
Okay. I like that. 58 degrees. So she said sine b over little b, so 58 over 82. Looks good. Sine 41 over x. Y'all can do the law of sines. Good job. Let's move on, shall we? I think we've got a good thing going here with anytime you've got 2 angles looking for a side, use the law of sines, sort of a rule. Jim wants to know the length of a tunnel built through a mountain. To do so, he makes measurements shown in the figure below. This is one thing I love about math is it's so real world, you know. Like, use these measurements to find. It actually really is real world, but at some point we have to like kind of try to find problems that match the math that you know, and that can kind of end up creating some kind of weird.
Just walk through the tunnel.
Come on, Jim. Get with the program here. Why don't you? What are you trying to do? Like reverse engineer it? I mean,
under the ground.
yeah, exactly. Well, no, we're looking down at him. Okay. It's just anyway. He's on the side, and the car is like flat. I don't know. It's like there's all kinds of things issues I have with this perspective. And what's going on with the mountain? Is the mountain?
What
like,
mountain looks
Exactly. So I don't know exactly. All
Did
right.
you not see the car?
If
they drew it looks like the lines.
If they drew it at the same level, he'd be in the mountain.
Yeah.
Right. It'd be kind of hard to tell that he was saying that. All in all, here we go. We're looking for this side, okay, and we've got two other sides and an angle, okay. Does anybody have a recommendation on which law we should use? I hear law of cosines, maybe because we've got two sides and an angle, like a side angle side situation. Absolutely. Okay. So if we called this little c and we call this big C, and this could just be A and B, doesn't matter which one it is. Our law of cosine says that any side squared is equal to the sum of the squares of the other two sides. So A squared plus B squared minus 2 times their product.
2AB
Then you just plug in the numbers, and the cool thing on this problem is we know this, we know this, we know this, we know this, we know that. And so you just go and you figure it out. How many problems we got here? Okay, last one. Mountain officials want to build a new ski lift. All about new ski lifts. From B to C, okay? Even better, because arguably this is probably a little bit further down the mountain, and it's going to take you to the same spot, so you can ski even farther. I always look for the longest possible trail that I can go onto. Go on if anybody ever ski, you kind of know what I'm talking about. You want to be like, oh, we go this, and then we go this, and we cut over across to this, and we go this, and then we can cut over here, and then we go all the way down to this part right down here. The idea is that way you spend the maximum amount of time on the slope.
Yeah.
Unfortunately, though, if you spend the maximum amount of time on the slope, then that normally means it's kind of like the least steep. So it's a little bit of a trade-off. But anyway, all right, super chair, all right, quad chair thing going on here. Maybe it's a gondola. And you just kind of go up there and look around. The distance from A to C, okay, this problem's looking a little bit more difficult. It's 14, okay, from A to C, okay, so 1460. They measure DAC, DAC to be 38 degrees, and DBC to be 21 degrees. What is the distance from A to B? Okay, what are some things we can figure out real quickly here, class?
Angle A. The other angle A.
Angle
Give me
BAC.
the angle BAC, I want the 3-letter name, thank you, is 142 degrees. Okay. And what are they wanting us to measure? From A to B, they're wanting us to measure that spot right there.
Angle C is 7.
Okay, so angle C is 17. You found that just by the triangle sum formula. Well, this looks like our go-to law of sine situation. You've got two sides, or sorry, we've got two angles, so that means really we have 3 angles. So we could say sine of one angle that we know over a side that we know. So sine of 21 degrees over 1460 is going to be the sine of that other angle we know, 17 degrees, divided by 142. Nope, question mark. And then you just solve for question mark. Sound good?
Yep.
So to summarize class, these are application-esque type of problems here. We found that if it was two angles, which really means three angles, then we used which one? Law of sines. What were the situations that we used the law of cosines?
Side angle, side, and side, side, side.
A side angle side and a side 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 situation. Fortunately, they didn't give us any of these that had two possible answers in that ambiguous case. Let's see what it is. See what your homework pops up. So you've got about 15 minutes if you want to start working on some of those problems or your topics. Okay?